Hi everyone, hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft and I'm also an educator at pre-level. So without wasting any time, we'll quickly get started now in this session with the very basic introduction about ER modeling. Before moving ahead, I would recommend that in the very first session about Introduction to Database Management Systems, we did touch upon ER modeling a little bit, where we classified ER model as one of the different database models which are available. So if you've not watched that video before, I would recommend first to go to that video and then come over to this one to have better context and understand this topic in even greater detail. So, entity relationship model is a model used to design and representation of relationship between data. So if you have some data, if you want to draw a relationship between them of how the data is related to each other, you use ER models for that. The main data objects or the main objects of concerns over in this data are basically termed as entities with their detailed characteristics and attributes known as the word attributes itself. Now, some of these attributes are very important as they use to identify the entity. For example, if student is an entity, then its attributes like age, name are important attributes because they actually identify what an entity is, right? And different entities are being related using relationships. So teacher and student is a relationship, right? And different entities and they are being related, so they have a relationship. Teachers and students, students and subjects, right? All of them are entities which are related to each other. And in ER models, we do represent all these relationships. So in short, to actually understand the ER model and taking a deep dive into that, we'll first understand a few things. What is an entity? What is an entity set? What are attributes and what are the different types of attributes? What are keys and what are relationships? Okay, how do you really represent relationships? So let's take an example. For a school management software, right, we have to store all the students' information, all the teachers' information, all the classes which we have information, all the subjects which are taught in each class. Okay, so what we're going to do is to actually understand the concept better, we are going to take a real life example itself and then understand all these terms. Okay, with this we'll get a better idea on what to expect and how to really design a system in a real life as well. So this is more like a hands-on and a practical way of learning this topic. So now we'll move ahead. First is ER model and we'll talk about entity and entity set. Now, considering the above example that I just introduced, we can very well say that student is basically an entity, teacher is also an entity, similarly class and subject are all entities, correct? An entity is generally a real world object only, which will have some characteristics, right? And which will hold some relationships as well. So based on that, we can say that in this ER modeling system where we are trying to draw some relationships, we can say that the entities that we have are student, teacher, class and subject. Okay, these are all the entities which are available. Okay, and what is an entity? An entity is nothing but a real life object which has some characteristics and it also holds some relationship with other entities as well. Now if student is an entity, then the complete data set of all the students will be the entity set. Now again, another term that we introduced over here, which is entity set, right? So you created an entity which is a student. Okay, student is one of the entities. Now it's more or less like it will be a student entity, correct? And in the student entity you will have the information for all these students, right? So an entity which holds the data related to that entity becomes an entire entity set. That's what it said over here as well. If a student is an entity, then the complete data set of all these students will become the entity set. Okay, so entity is more or less like a real world object. When you have the complete data related to that entity, it becomes entity set. Okay. Next, we talk about attributes. Now, if student is an entity, then attributes like student roll number, student name, student age, student gender will be its attributes. So it's more or less we represent it like this. If student is an entity, right, its attributes, its characteristics are roll number, and what all we have student's name, we have student's age, we have student gender. So these are the attributes which will uniquely identify a student. So these are all attributes of an entity called student. Now an attribute can be of many types. Once we identify what an attribute is, we can classify them into many types. Okay, and here are the different types of attributes defined in the database model. First is going to be a simple attribute. Now I think the ordering has been changed a little bit. There are a total of 5. The first is simple attribute. The attributes with values that are atomic and cannot be broken down further are simple attributes. Okay, so an attribute which is simple, which is atomic, it cannot be broken down into several parts, right? It is known as a simple attribute. For example, a age of a student is a simple attribute. Second are composite attributes. Now, a composite attribute is actually made up of one or more simple attributes. So it's like a accumulation of simple attributes. For example, a student's address will contain house number, street name, pin code, etc. Right? We could have stored all of these as different attributes also, or we combined all of them and made one composite attribute as address. Okay, so what we could have done was either we could have just stored the address over here, which will have the city name, the pin code, the apartment number, or the other thing that we could have done is we could have made it separate. We could have city name different, we could have pin code as different, we could have street name as different. Okay, so if you store it all of it together, this is known as a composite attribute. But if you store them all differently, they are individual or simple attributes. Okay. The third is the derived attribute. These are the attributes which are not present in the database system, but they are derived using other attributes. Okay. For example, if I want to say that I want to find out the average age of a student in a class. Okay, so we have an entity set which has the age for all the students, right? Now using that, I derived another attribute which is the average age. Okay, let's say I introduce another one over here, which is the average age. Now this attribute as such is not present in the data. Okay, we have no data available for it. We actually derived it using all the individual ages of the students, and we just took the average of that. So these attributes are not available as such for any data, but they are derived and calculated from the attributes which are already available. Fourth is single valued attribute. So first is simple, second is composite, third is derived, and the fourth is single valued attributes. So as the name suggests, they have a single value. For example, you have an age of a student, right? Now age is a single value, right? You'll have just one value attribute. Then we have multi-valued attributes, right? As in, they can have multiple values over here. For example, if let's say you are storing the phone number of a student, the phone number for a student can have multiple phone numbers. So an attribute can have multiple values associated with it. So that's known as a multi-valued attribute. Single valued when it just have a single value. Multi-valued is when it has multiple values available with it. Okay. Next, we talk about keys. Okay, now keys in detail, I think we've already talked about in the session of keys and normalization. So if you've not watched that video, I would recommend to, watch that video. It will give you a good idea about keys where the detailed discussion is happening, and then you can come over here. So ER modeling in terms of keys means that if the attribute roll number can uniquely identify a student entity amongst all the students, then the attribute roll number will be said to have a key. Okay, you remember in the school, every student, right, was not just identified with their name, because names are not unique, right? A person who can have a name Aman, another person in the class could also have the name Aman. So when I call Aman, I'm not really sure which Aman I am calling. But if I use roll number, right, and that's what used to happen in school as well, right? Every student used to have a unique roll number, right? So when I call 3, it means the first Aman. And if I call roll number 4, that means it's the second Aman, right? So it is very easy to identify students, right, based on their roll number. And if there is an attribute which can uniquely identify a student, right? Now, roll number is enough to identify a student uniquely. But let's say if I say name, and let's say in that name I call Aman. Now, just saying Aman is not enough to tell me whether which Aman I am really calling, right? So in that case, name is definitely not a unique attribute or a key over here, but roll number can be a unique attribute which can identify a student amongst all these students. So roll number can be considered as a key, and in very specific example, it can be considered as a primary key. If you've not learned about keys before, I would recommend to watch that video first for keys and normalization. We've talked about super keys, we've talked about candidate keys, primary key, foreign key, and a lot more keys, right? So there you'll get better idea. But understand that the component or the part of keys is very important to define the ER models. Last but not the least is what we have in terms of relationship. Now, when an entity is related to another entity, they are said to have a relationship. Now, teachers are going to teach some subjects, right? So, teachers and subjects have a relationship, okay? These are the two entities which are related to each other. For example, a class entity is related to student entity because the students study in a class. Hence, it's a relationship. Every student will be studying in a particular class. So, a student and a class entity are related to each other. Hence, this is a relationship. Okay. Now, depending on the number of entities involved, a degree is associated to relationship, right? So, that means if I am, let's say, related to 3 entities, right, then there's a degree that is associated. For example, if 2 entities are involved, it is said to be a binary relationship. If in the entire system there are 2 entities, that means it is said to have a binary relationship. If 3 entities are involved, then they are known to have ternary relationships. Okay, so that is what relationship means, that if you have certain entities, they are definitely going to be related to each other. For example, a class will be entity will have a relationship to student entity. Similarly, students entity will be related to subjects entity also. Similarly, teachers entity will also be related to subjects entity. So, based on the number of entities now we have, we can also define a degree. Okay, so this pretty much concludes what we are supposed to do in this video. We started with the very idea about what ER models is, right? They are very much dependent on entity and relationship. The very word entity is just a real world object of concern, and relationship is how we connect two entities. Okay, and we understood the fact that a few things are very important to understand the important keywords which will help us to design ER models. We took the example of a real life software management, school management software to understand this topic. So when we talk about entities, objects like student, teacher, class, subject, they form entity. And the entire data set for an entity, for example, teacher, the data set for all the teachers make up the entity set. Okay. Then we talked about what attributes are. Attributes are something which are characteristics of an object, right? Attributes are characteristics for an object which helps to define some properties that an entity possesses. Okay, now an attributes can be of multiple types we talked about. Simple attribute, it has just one atomic value and it cannot be broken down. Composite attributes, that means it's derived from a few attributes, right? For example, address is a composite attribute of which is derived from simple attributes like house number, street name, pin code, etc. Derived attributes are the one which the attributes are not available in the database management system, but using the available attributes, we derive that attribute. For example, the average age of the students in a class. Next one are single valued attributes. For example, for an attribute, when we know there is only a single value that will be associated. For example, age. A student will have just one age, so the value will always be single. Then we talked about multi-valued attributes where the values can be multiple. For example, for a student, it can have multiple phone numbers. Next, we talked about keys. When we have an attribute which can uniquely identify a particular student or a particular teacher amongst all the students, then it's known to have a key. Okay. Similarly, if it's a group of teachers, two teachers can have the name Anupama, right? But if I have unique teacher ID, I can basically locate and identify a particular teacher. Okay. And there are a lot of keys which are available. To study about this in detail, please refer to the keys and normalization video. Then we talked about relationship, that if you have multiple entities, they are bound to have relationships. And based on the number of entities involved, we define the degree as well to have relationships. So if it is 2 entities, we have binary, 3, we have ternary, and so on. All right. So I hope this helps you to understand the basics about ER modeling. The next sessions will focus on how do we create ER diagrams, how do we understand the concepts of generalization, specialization, and how do we go deeper into this concept. So stay tuned for these videos as well. Please make sure you go through this and understand this topic once on your own as well for better clarity. And I will definitely meet you in the next one. Thank you so much for attending. Bye.